Hello everyone, welcome back to CHM 577 in Organic Chemistry. So for today, we are going to continue with the hybridization and valence bond theory, or known as VBT. So the first one is where we will be discussing on the mode of orbital overlap, because as you know, we have overlapping of molecular orbital that creates or that form the sigma and also pi bonds. So let's go to the first one, a single bond. Single bond means a sigma bond. Alright, so let's recap our knowledge. Whether you still remember that if we have a single bond, we have one sigma bond. If we have double bond, we have one sigma bond and one pi bond. Alright, and if we have a triple bond, we have one sigma and two pi bond. Alright, okay, so in this mode of orbital overlap, I will explain to you on the sigma, the formation of sigma, the overlapping of how overlapping of orbital on how sigma and also pi bond can be formed. Right, so if you have a single bond, it means that or if you have a single bond, this will show you a sigma bond. Right, so in this case, you can see, right, this is ethane. We have where the molecular formula is C2H6. All right, so in this structure we have 6, right? Sorry, not 6, 7 sigma bond, where you can actually determine them by, alright, so let's see. In this ethane, so this is another first sigma bond, second one, third one, fourth, fifth, and then sixth, and last one is the 7 sigma bond. Alright, so how this actually sigma bond can be formed? Right, so it is actually formed by sideways overlapping of two atomic orbitals, or sometimes we call it as end-to-end overlapping. End-to-end overlapping. Alright, and then what happened here, when the end-to-end overlapping, the electron density is concentrated along the internuclear axis. So here, I have let's say, for example, here this is the s orbital, the end-to-end orbital of the s orbital that form a sigma bond here, right? And then the p orbitals, we have two p orbitals overlap end-to-end, alright? Also, it will form a sigma bond, while for this one is the hybrid orbitals. It also, all these three are forming sigma bonds. Right, another one, second one is the pi bond in ethylene. So this is the shape, alright, the overview of the molecule, of the ethylene molecule that has something to do with the orbitals of carbon. Alright, so the molecular formula for ethylene is C double bond C. So we have the hydrogen here. Alright, so as you know, double bond will produce or will be having one sigma and one pi. So interaction or the bond between carbon and carbon here will form a sigma. Carbon and also hydrogen will form another sigma. Same goes to here, here, and also here. Alright, but this is n, all the sigma are showing you that the end-to-end overlapping, but if you have the side-to-side overlapping, it will give you a pi bond. Alright, so a pair of these overlapping of this side to side will give you equal to one pi bond. Alright, so so a pair of these two will form one pi bond. And the angle here between hydrogen, carbon, and also carbon here is 120. So it will give you what we call a trigonal planar. Okay, so this is another diagram for ethylene. Alright, so this is where you can see the formation of a sigma and also pi bond. Alright, so the pi bond is where the electron density move, where the electron density above and below plane, alright, of a nuclei of the bonding atoms. Okay, and then the sigma bond is the electron density is concentrated around the internuclear axis. Alright, so that's the end for this part, the mode of orbital overlap. So I'll see you in the next video. I hope you enjoy this video and thank you. Bye.